This is Mr. TG. This is lesson 11.8 in Algebra 2B. Binomial distributions is the title of our lesson. The first video that you're going to watch will be the video that I demonstrate on how to expand binomials. And you can do that two different ways. One, using Pascal's triangle, which I'll demonstrate, and the second way is using the binomial theorem. First, I thought what I do is show you what it means to expand a binomial. Some of you may not know what that means when I say that. So just give you an example. Let's say I have x plus 5, and I take that to the second power. So we got x plus 5 to the second power, and I'll set that up. Hopefully, from the past experience, you know that's the same thing as x plus 5 times x plus 5. And when we FOIL that, we get x squared plus 10x plus 25. That is one way of expanding x plus 5 squared. That's what we call expanding. Now, what do you think would happen if I took x plus 5 to the third power? Well, if we're going to expand that, we'd multiply the first two. Remember, this is the same thing as x plus 5 times x plus 5 times x plus 5. There are 3x plus 5s. We already multiplied the first two and got that result. Then you would have to take the third x plus 5. And the way we multiply those out is we line them up. You multiply 5 and 25 is 125. 5 and 10x is 50x. 5 and 5x squared is 5x squared. Then we take x times 25 is 25x. Notice I'm lining them up, the like terms as we go. 10x squared would be x times 10x, and x to the third. And we end up with x to the third. Add these terms up, you get 15x squared plus 50 plus 25 is 75x plus 125. So that's a lot of work just to create the multiplication of three binomials. And imagine what it'd be like if I put a 4 here, or maybe even a 5. Again, we are looking at expanding binomials, but we don't want to have to go through all this work. So what we're going to do is erase this and show you an alternative way of this expansion. Let's go up to the top, and the most popular way I like to teach it is with Pascal's triangle. That's this thing right here. It is a triangle that has certain patterns. It starts off at the top with 1, then we have 2 1s, and you'll notice that the 1 plus 1 is 2 here, 1 and 2 is 3, 2 and 1 is 3, and we could keep adding on to this level if we'd like. So this next level would be 1, 5, 10, 10, 5, and then there'd be a 1 at the end. That would be your level that would correspond with x plus y to the 5th power. All right, so but that's called Pascal's triangle. Pascal is the one that invented this, and what we're gonna use to actually expand x plus 5 to the 4th power. And hopefully for you it'll be a little bit easier. Now x plus 5 to the 4th power, the first thing we do is let's get rid of this level here because we don't need it right now. We do need this level, however, right here, this x plus y to the 4th power. Immediately, Pascal's triangle tells me how many terms I'm going to have. There's going to be 1, 2, 3, 4, 5 terms. So let's make a list of those numbers that are in the triangle. There they are. And I know there's going to be 5 terms. Now, what you do after that is you take the first term in your binomial, you raise it to the highest potential exponent that you can, which is 4, and descend the exponents. So we just go all the way down to x squared, x to the first, x to the 0 power. Then you take the 5, the second term, and ascend the exponent starting at 0. So you end up with 5 to the first, 0, 1, 2, 3, and then this is 5 to the 4th power. And then we'll put plus signs in between. If this is plus, they're all going to be addition. And then, folks, all we have to do is simplify. Now, 5 to the 0 power is 1 times x to the 4. That's just x to the 4th. 4 times 5, there's a 5 to the first here, times 4 is 20. x to the third. Simplifying over here, that's 25. Remember, 5 squared is 25 times 6 is 150, x squared. Then plus, we got 5 to the third power here, which is 125. 5 to the third power is 125. Times 4 would be 500 x, and then plus 5 to the fourth power at the end would be 2625. Running out of room here, so I apologize for squeezing this in here. But that would be your final answer if you expanded x plus 5 to the fourth power. Now, what I want you to try and do is expand number 2 using Pascal's triangle. It was a little bit easier on you because we're only doing the third power, so I'm going to erase this. So I'll make sure you copy all that down, and let's erase this. And let's go through this expansion with Pascal's triangle with 2x minus y. This time it's to the third power, so we're going to ask you to try and expand it using the first example as a reference. I'll hit pause. When you come back, I'll have it worked out for you, and hopefully we'll match answers. If not, I'll explain how we come up with those solutions. Okay, welcome back. Here's how I set this up. I've got all the work in place now. The first thing you do is identify which level of Pascal's triangle you are going to work with. It's the third power, so we use the x plus y to the third power. There are 4 numbers in Pascal's triangle, which indicates 4 terms. And what I'll do is I'll demonstrate here where those went. Right here, there's a 1, 3, 3, and 1. Then I take the first term, which is 2x, raise that to the highest potential exponent, which is 3, and make sure you use parentheses because you're taking 2 and x to the third power, then to the second, into the first, and to the 0 power. And you don't actually have to put 2x to the 0 power there if you don't want to, because we know that's by definition 1. Then we take negative y to the 0 power. We ascend those exponents, 1, 2, and 3. And basically, it's just a matter of identifying the numbers in Pascal's triangle and using the patterns presented. Now we simplify. 2x to the third power is 8x to the third. The rest of these terms turn into 1s. Then over here we have 4x to the second power. That's what this turns into, which is 4x to the second power. Times 3 is 12. And then you have a negative y here, which makes it a negative 12. And you get y. This negative y squared is y squared. And then we've got 3 times 2, which is 6. So we end up with 6xy squared. And then we end up with here 2 1s. And then a negative y to the third, which is negative y to the third. Notice again, there's patterns that are involved here. You can see that the coefficients may be different, but the x to the third, x to the second, x, and y, the x disappears, and then the y ascends. Also, please note that if there's a minus inside, it's called the Carty's rule of signs. You'll basically, signs will switch. You'll start with a positive, then a negative, then a positive, and a negative, and it will continue for as many terms you have in your answer. So hopefully that went well. And this basically shows you how to expand binomials using Pascal's triangle. Now what I'd like to have you do is show you how to use the binomial theorem. Now what we're going to do is expand x minus 3 to the 5th power. It's very similar to Pascal's triangle. The only difference is you use this formula, and the combinations here are basically what we're going to use to create the numbers that come to us from Pascal's triangle. Now that would be, if we had another level here, 1, 5, 10, 10, 5, and 1. But if it gets too large of an exponent, it gets not very practical to actually make that triangle so large. So what we'll do is show you how to implement the formula. And by the way, you may be asking yourself, why are we expanding binomials in a chapter on probability? This binomial theorem, as you will see in the next Pearson videos, has a lot of application for finding probabilities, which we'll get into later. Okay, so let's go to work. First thing you want to do is, this is your n term. The n is 5 is n. So we go 5, C 0. And then you take, it says a to the first power, which is your first term, to the fifth power. See that we did that in the top problems. That should complete our first term, and they ignore the negative 3 to the 0 power. Since they're always 1, you can ignore that. Plus 5c 1. And then notice it says a to the n minus first power. All they're doing is taking the x and subtracting an exponent from it, 1. And then now they take the negative 3 to the first power. Notice that's b to the first power there. And then plus, and you do this as many times as you need until you run out of terms. 5c2, x to the third power, negative 3 to the second power, plus 5c3, x to the second power, negative 3 to the first power, and then 5c4, I have to go down to this line, x, and by the way, this should be negative 3 to the third power, excuse me, and then this would be x to the first power, negative 3 to the fourth power, and then our last term finally would be 5c5, and there would be no x term because now we're at x to the 0. We just have a negative 3 to the fifth power. Okay. Now what I want you to do is take your calculators and work, if you have to, you can use Pascal's triangle and just work all these combinations out and then simplify it and see if you can match my answer that I come up with when I simplify. And I'll hit pause and let you continue. Okay, welcome back. Hopefully you can read my writing here. We have, I think I set it up for you here. Now what we did first, or what I did first, was I converted all the combinations to actual numbers. You can see again they correspond with the Pascal's triangle. And then I simplified the exponents where possible. We got x to the fifth there still. Negative 3 to the first is negative 3. Negative 2 squared is 9. Negative 3 to the third is negative 27. And then we got 81 here. And that's 5. And then that's 729. And that should be a negative there because we end up with 5 negatives, which makes this sign negative. Now, I think we're ready for our grand finale. We're going to put all these together in one roll. So our first term right here would just be x to the fifth. Let's write that down. Okay. Our next term would be a negative 15 x to the fourth. Write that down. Notice our signs are alternating, which they should because the minus here. The third term would be 90 x to the third. The next term would be a negative 27 times 10, which is a negative 270 x squared. And then we've got an x here. We got 5, so that'd be 405 plus 405. Doing this one right here. This is an x, not times. So 5x times 81 is 405x. And then our last term would be a minus 729. There is our expansion of x minus 3 to the fifth power. Again, you can see that the exponents descend. The coefficients also are always different depending on what kind of numbers you have in your binomial. So hopefully this went well. Now the next videos will be with Pearson. Your last piece of paper that you have to do is once you get done watching the Pearson videos, you should be in a position to be able to answer the questions that are on the very last page. I provided you with 2 forms, one for your notes and one to be turned in to me. Please let me know if you need help on those. I'll be glad to help you, but it is your responsibility after you've watched the notes to complete that and turn that in to me the next day. You get to keep the actual notes until the test day. So good luck with this, and let me know again if you have questions.